This is Mr. Gillum, and today we're going to look at some positive and negative numbers again on page 116 of your instruction book. It says, what number is the opposite of 5? What can you say about the opposite of a number? So let's think about this problem on a number line. It says that we're talking about the number 5. That's where 5 is. We're talking about opposites, so I'm going to write where negative 5 is as well. Okay, so here's a number line illustrating each one of these dashes represents a whole number, 1, 2, 3, 4, 5. I've labeled 5 and negative 5, and it asks us what is the number, or what number is the opposite of 5. Okay, so when we read this question, it can be kind of confusing because it has the word opposite in it twice. So we need to figure out what the opposite of 5 is. So I know that the opposite of 5 would be negative 5. So the opposite of 5, this part of it right here, is right here. This is the opposite of 5, negative 5. Here's where I'm at now. I want to know what the opposite of that number is. The opposite of negative 5 would be 5 again. So the opposite of 5 would be 5. It would be 5 itself. So here's what we can say. The opposite of 5 is negative 5. The opposite of negative 5 is 5. So the opposite of 5 is 5. The opposite of a number is the number you started with. So when we talk about the word opposite, it almost always refers to a negative sign. So what we could be thinking is, what number is the opposite of 5? So we would like the negative version of negative 5, if that makes sense, or if that helps you at all. So the opposite of negative 5 would be positive 5. Maybe that helps you if you write it in symbols instead. A lot of times when we talk about the opposite of a negative number, we put that number in parentheses, so you may see it like that as well. But remember that the word that negative and opposite are pretty interchangeable in mathematics, so if you see a negative sign you prefer, it makes sense better to think of it as the opposite, then you may do that as well. It says positive or negative numbers can show an amount above or below 0. They can also be used to show an amount above or below a certain point. Students at Taft Middle School have a goal of collecting 1,000 pounds of recycling material each month. The following table shows their results over a 6-month time period. Complete the table. The first month is done for you. So you can see that in January they collected 985 pounds and their goal was 1,000 pounds. And so because they did not reach their goal, they were under their goal. They were 15 pounds under their goal. We could represent that when we're comparing to 1,000 as negative 15. So they were 15 pounds under. In February, they collected 1,010 pounds. So I know that 1,010 is actually more than 1,000, and it's 10 more. So I was over my goal by 10, so I could call that positive 10. Now I could write the plus sign in front of the 10, but that's really not necessary, and I don't want to get into a bad habit about that. We know it's positive, we don't need to write the plus, so 10 is fine. Again in March, they only made it to 995 pounds, so they didn't quite meet their goal. And I'm subtracting because I know that I want to see how far they came away from their goal. So they were 5 pounds away and they didn't make it. They were under, we use that word, under their goal. So I know that I could represent that as they were under by 5 pounds or negative 5 pounds. Okay. I think you get the idea to figure out how much or how close they were to 1,000 pounds. And the reason I'm comparing to 1,000 is because their goal was 1,000 pounds. So you actually read the question and make sure you understand what their goal is, or it's going to be difficult to figure out positives and negatives. So 1,050 is 50 above their goal. So we could represent that with 50. 975 is below their goal. It's below their goal by 25. So I could represent that with negative 25. 980, again, they didn't quite reach their goal. They were under their goal. Because they were under, we consider it negative. They were negative 20. They were 20 away from meeting their goal. In this case, these are the only two positive values, and that's because they were above their goal. So we consider them positive. And so that's how we compare using positive and negative numbers. says look at the number line below. The letters A, B, C, and D all represent integers. Ooh, okay, I like this problem because this is a lot like what you're going to see on the park. You're going to see the number 0 representing the middle of the number line, and you're going to just see letters, not numbers. And so you have to do is you have to actually understand how a number line works. So there are a few things about a number line I want to remind you about. 0 is in the center. It has no opposite. It's its own opposite. It's neither positive or negative. The positive values on a number line are to the right. The negative values are to the left. The farther to the right on the number line, the farther to the right is always greater. Okay, if it's to the right, if you're comparing two numbers, the number to the right is greater. If you're comparing numbers, the number to the left is less than. Less than or greater than. Greater than is represented like this, less than is represented like that. Okay, it says which letters represent negative integers. Okay, so I see 0. My 0, my middle line there is highlighted here in the middle. My negative numbers are the ones to the left. So regardless of what A and C are, I know they must be negative because they're on the left side of 0. So I know that A and C are both negative because they're to the left of 0 on the number line. Which letters represent positive integers? B and D do. They're to the right of 0 on the number line. And then if B and C are the same distance from 0, how can you describe them? Well, it doesn't matter if B is 2 and C is negative 2, or B is 5 and C is negative 5, or B is 0.1, C is negative 0.1. It doesn't matter because it says that they're the same distance. This distance and this distance are the same distance. So if that's the case, we know if they're on either side of 0 that they must be opposites. They're opposites. Okay? So that's how a number line works. I want you to really be careful in that. It may ask you, let's do actually a few more problems real quick, to compare A and B. Let's compare A and C, B and D. We're going to compare these with greater than or less than signs. B and C. Let's do D and A. Okay, let's just compare each one of these. So let's start with A and B. This is where A is, this is where B is. The number farther to the right is the number that's greater than, so that's where my inequality should be opening towards. So in this case, A is on the left and is smaller than B. Again, my inequality opens towards the greater number. B is farther to the right. It's also a positive number, so I know for sure all positive numbers are greater than negative numbers. It should open towards B. If I compare A and C, I have two negative numbers. These sometimes are confusing because if I assign like number values to C and we called it -2 and I called A -8, it's going to be very tempting to say that 8 is greater than 2. But because we're on the opposite side of the number line, it actually works the opposite way with your inequality. C is actually farther to the right than A. It's farther to the right. So again, C is where it should be, my inequality should be opening towards. C is actually greater than A, or we could say A is less than C. If I compare B and D, these numbers, even though there's no numbers assigned to them, I know that the number farther to the right is always the greater number, so my inequality should be opening towards D. So again, I could say this is D is greater than B, or B is less than D. When I compare B and C, again, I'm always identifying which number is bigger, and I know B is bigger because it's farther to the right, so I know my inequality should be opening towards B. We could say that B is greater than C, or you could say C is less than B. Would be an equivalent statement as well. Finally, let's compare D and A. D is way over here, A is way down here. Regardless of what the numbers are, the number farther to the right on the number line is always the greater number. So farther to the right is the greater number, D is the greater number. I must open my inequality towards D, so D is greater than A. It doesn't matter what the numbers are. I know this because I know how a number line works. I understand that farther to the right, the numbers get larger. Farther to the left, the numbers get smaller. And that's exactly what you need to understand as far as the cardinality of your number sense. So that's it for today.